Bitcoin Core.
So today we'll be introducing the conceptual architecture of Bitcoin Core. So this system was developed by an anonymous user called Satoshi Nakamoto. It uses a decentralized system of currency and uses P2P network and public key cryptography. And also the currency itself comes from the process of Bitcoin mining.
The derivation process was to get a secure system from unwanted peers and other people. They want to keep track of the transactions between each peer and have a place to store coins and a way to get your coins, your currency.
So that's how we get the components for all the, for example, blocks or wallets or connection managers. So and then an alternative of this could be integrating some of the components into one. So that simplifies the system a little bit. And the advantages is that it's less costly to maintain and make all the components. But a disadvantage would be it's harder to debug because there's a lot of dependencies and we don't know which aspect of the problem causes this problem.
The architecture style of this system is the peer-to-peer style, since the whole network is based on connecting peers and having each connection be of equal amount, and there's no hierarchy or set server type network. It is all connected between each people. The conceptual architecture has a few different parts. First, there's the parts that connect, the components that connect to the network with peer discovery and connection manager, which go through all the IPs and make sure every peer is connected to each other, and it can ban unwanted peers or people to keep, so it keeps the whole network under control. There's the blocks, which can be put into a blockchain, which keeps track of all the transactions between all the peers. The mempool is also used to build the blocks, since blocks, before they are confirmed to be going to the blockchain, are waiting in mempool. The miners are what solves the hashes to get the blocks into the chain, and all the miners who get their coins will have it go to their wallet, which can be seen on the app.
So the data and control flow of the system is basically we have transaction, which is formed as a form of data. And so it flows through all the components. For example, when a user makes a transaction, we'll have to go for the connection manager and the wallet because it will need to be encrypted using some public and private keys. And then it will go through a hashing component, also going through the validation engine component, the mempool component, and finally the storage engine. And so for the control flow, the connection managers controls many of the components used in the system. For example, wallets and TXS, which is for hashing of the transaction. So its use is mainly to establish connection and confirm transactions. So evolution of the system. So here we present one of the most recent versions of the Bitcoin system. So Bitcoin 0.21.1 features something called Taproot soft fork, which improves efficiency and privacy. And the latest version is Bitcoin 22.0, which uses Invisible Internet Project service and only supports Tor v3 and not v2.
The external interfaces and data and files that are shared around and sent around with the system. There's the network data, which holds all the IP addresses of the peers and the list of which peers are welcome and which ones are not. There's blockchain data, such as the data that is in the mempool before it is sent and like verified to be into the blockchain, as well as the state of the blockchain and the cases of the parents and children blocks. And then there's also the miner signals, which go off when a miner has gotten the solved the hash and has gotten their coin, so it can be told that that person got it. And there you can also see all your wallet on the app.
So our first use case is that a user makes a transaction to another user. So first we can see the agent, which is the user here, and then it requests transaction through the interface, which will then establish connection for a connection manager. And then after that, it has to establish an secure connection. So it will have to request encryption keys from the wallet and and a hashing algorithm from the TXS components. After that, it will call the mempool validation engine and blocks to confirm and validate the transaction. And then at the end, it will update the storage engine to update the number of Bitcoins that the user has.
And in the use case for the second one, the participating as a node, the user requests connection to the application, and the connection manager will establish the connection where the peer discovery will get the nearby peers and update the list of peers that are connected. And then you can request your key for encryption to get into your wallet, and it'll return the keys of what's in your wallet.
So after this project, we learned how to research different sources to understand a given architecture. In this case, it would be Bitcoin architecture. And also during the process of this project, it was very difficult to meet all the group members because we had different time schedules and different accommodations. So it's very hard to work on it with everyone present. And at the end, we had to rush with very few number of people. So after this, we learned how to have time management and group management. And also we learned how to apply software concepts in daily life and on this project.
In conclusion, the system has a peer-to-peer architectural style, and many of the components have ways to protect the data and keep it secure, with security being a high priority. There's well built-in system for evolution and testing to continuously improve the Bitcoin system, as it's open sourced and many developers can help improve it. And in the future of our projects, we're going to continue to explore in more depth the aspects of Bitcoin Core.